Hello, my dear students, and welcome back to the channel. I know, exams are just around the corner, and the tension is building up. But please, don't worry. Today we are going to tackle circles, and trust me on this chapter is going to be your secret weapon for scoring full marks. So let's just dive right in.
So just take a nice deep breath and forget all that exam stress. For the next few minutes, it's just you and me. Your only job is to watch and to understand. I'm going to make this so simple, so crystal clear, you'll actually wonder why you ever worried about it. Jalo, together, let's make this chapter your easiest score.
All right, first things first. We see a circle, right? And then we see all these lines buzzing around it. So what are they? What is a secant? What is a tangent? And more importantly, which one is the hero of our story today? Let's find out.
Okay, look at this. There are really only three things that can happen when a line and a circle meet. Imagine a line flying towards the circle. First, whoosh, it can miss it completely. We call that a non-intersecting line. Simple. Or it could slice right through it, hitting it at two different points. That, my friends, is a secant. But the third case, that's the special one. The line just gently touches the circle at exactly one single point. And that is our hero, the tangent.
So let's make it official. What's a tangent? It's a line that touches the circle at exactly one point. Bilkul simple. And that one special spot where they meet? It has a name. We call it the point of contact. See? Easy to remember.
All right, now that we know who our hero is, it's time to learn its secrets. And look, I'm not going to call them boring old theorems. No way. For us, these are secret rules. They are superpowers that will help you solve any question the exam throws at you. So let's get into the first one. And here it is, secret rule number 1. The tangent at any point of a circle is perpendicular to the radius at the point of contact. Now, the magic word here, the word you have to remember, is perpendicular. What does that mean? It means they make a perfect 90-degree angle.
This picture shows it perfectly. Just look at the diagram. You've got the center, O, you have the tangent line, XY, and where do they touch? At the point of contact, P. The line joining O and P is, of course, the radius. And what's that little square symbol at P? That's our 90-degree angle. This is the superpower. Wherever a tangent and a radius meet, boom, you have a right angle. Now you might be thinking, Sir, how do we know this is always true? You won't believe how simple the proof is. Just take any other point on that tangent line. Let's call it Q. Now Q has to be outside the circle, right? If it were inside, the line would become a secant. So this means the distance OQ is always going to be longer than the radius OP. And what did we learn back in our junior classes? The shortest distance from a point to a line is always the perpendicular distance. That's it. So OP has to be perpendicular.
So there you have it. QED. But not what the textbook says. For us, it means quite easily done. See? Nothing to be scared of at all.
Okay, enough of the theory. The real fun in math starts when we actually apply these rules to solve problems, isn't it? So let's take a typical exam-style question and see how our new superpower actually works. You ready for this?
Okay, here's the question. We have a tangent, PQ, at a point P. The circle has a radius of 5 centimeters. The distance from the center O to a point Q on the tangent is 12 centimeters. The question is, what is the length of PQ?
Okay, first step is always to draw a quick diagram. Here's our circle, our tangent PQ, and the lines connecting everything. Now, pause and think, what does secret rule number 1 tell us? That the radius OP is perpendicular to the tangent PQ. As soon as we mark that 90-degree angle at P, what do we see? We see a right-angled triangle, OPQ. And that, my friends, is the key to solving this problem.
And whenever you see a right-angled triangle, what's the first thing that should pop into your head? Our old friend Pythagoras. Hypotenuse squared is equal to the sum of the squares of the other two sides. So, OQ squared equals OP squared plus PQ squared. Now we just plug in the values. 12 squared equals 5 squared plus PQ squared. We do a little bit of calculation, and we find that the length of PQ is the square root of 119 centimeters. It's that simple. Our secret rule made it happen.
Fantastic. You've mastered the first rule. So, you're ready to level up. Let's move on to the second secret rule, which is just as powerful, if not more. This one is like a buy one, get one free offer, because it deals with two tangents at the same time.
So secret rule number 2 is this.
If you pick any point outside the circle and you draw two tangents from that single point to the circle, their lengths will be equal. Always, no matter what. This is another super useful trick. The key word here is equal.
Just take a look here. We've got an external point, P. And from P, we've drawn two tangents. One is PQ, and the other is PR. Our rule says that the length of PQ must be equal to the length of PR. But how do we prove it? Well, it's all about finding two hidden triangles. Can you spot them? We have triangle OQP and triangle ORP. Let's take a closer look at these two.
The whole trick is to prove that these two triangles are identical, or as we say in maths, congruent. We'll use the RHS rule. So, R is for right angle. We know angle OQP and angle ORP are both 90 degrees. Why? Because of our secret rule number 1. Next up is H for hypotenuse. The side OP, well, that's the hypotenuse for both triangles. It's a common side. And finally, S for side. OQ and OR are both radii of the same circle, so of course they are equal. So RHS is satisfied. The triangles are congruent, and that means their matching sides, PQ and PR, must be equal. So simple.
All right, you have learned both the secret rules. You've practiced a simple question. Now it is time for the final challenge, the boss level. This is the kind of question that really separates the toppers from everyone else. But you know what? You are ready. Let's use both of our secret rules to completely defeat this problem.
Take a good look at this question. We have a circle with a radius of 5 centimeters. Inside there's a chord PQ, which is 8 centimeters long. Now, the tangents at both P and Q, they meet at an external point T. Our mission, should you choose to accept it, is to find the length of the tangent TP.
Now, I know this diagram looks a little complicated, but it's not. Let's just break it down together. We know the radius OP is 5, and the line OT cuts the chord PQ at R. Now, because of symmetry, OT is the perpendicular bisector of PQ. That just means PR is half of 8, which is 4 centimeters. Now think, what do our rules say? Secret rule number 2 tells us that TP must be equal to TQ, and secret rule number 1 gives us a right angle at P in the triangle OPQ. We have all the clues we need to solve this.
The most elegant way to solve this is by using similar triangles. First, look at the small triangle PRO. We can use Pythagoras to find the length of RO. We have PO squared equals PR squared plus RO squared. So 5 squared equals 4 squared plus RO squared. A quick calculation tells us RO is 3 centimeters. Now triangles TRP and PRO are similar, which means the ratio of their sides is equal. So TP over PO equals RP over RO. We know PO is 5, RP is 4, and we just found out RO is 3. So TP over 5 equals 4 over 3. Just cross multiply, and you get TP equals 20 by 3 centimeters. And we did it. We have defeated the boss level problem.
Phew, that was amazing work. You've learned everything you need to become a champion of circles. Before we finish, let's just quickly go over the most important points one last time for your exam revision.
Just burn these 3 magic points into your memory. 1. A tangent touches a circle at only one point. 2. Secret rule number 1, the radius and tangent always make a 90-degree angle. And 3. Secret rule number 2, two tangents from one external point are always equal in length. If you remember these 3 things, I promise you can solve any question. You are now fully prepared. You have the knowledge, you have the secret rules, and most importantly, you have the confidence. So go into that exam hall and just ace it. I know you can do it. And hey, if you found this explainer helpful, please do hit that like button and share it with your friends who might also be stressing out. And if you still have any doubts at all, just drop them in the comments below. I'll do my very best to answer every single one. All the very best.